the best thing I could ever.
Thanks everyone for joining. Got YouTube coming in here, fixing up TikTok. Today's stream is entitled Palindrome Linked List or Ego Death. And the reason is because I'm going straight from one online assessment to another and my brain hurts. You can see on the LinkedIn post in front of us, we're starting 12 minutes late because I had to take like every last second. Actually, the assessment cut me off before I was done. I still managed to pass, even though I didn't score 100% of test cases. It's divided into a multiple choice section and then two like LeetCode code problems, basically. And one of those LeetCode code problems, I passed all the test cases, and one of them I passed like a large proportion, but not all of them. So you can get partial credit, basically, which is the only reason that I passed. Because if it was like all or nothing, maybe that's not the only reason that I passed. If it was all or nothing, I would have missed the second LeetCode code problem. But I don't know how that would have affected the percentages. Maybe I still would have gotten above 80 overall. But yeah, in hired.com, they don't let you use Python. Today I learned. I was like trying to switch over to Python. I was like, it has to be JavaScript. And then like the IntelliSense is like not telling you all the things available. I'm like, is NaN, is that on the numbers object or is it just globally available? I'm like trying to remember and logging the console to remember the API. It was painful, but we made it. Look, Ma, we made it. Okay, so that's the reason that we're starting up a little bit late. Well, let me not close it. I'm going to deal with that later. Let me bring it off screen. Linked list cycle. Right, so now let's go over to the LeetCode kata. Switching gears here. LeetCode kata on the ladderly.io blog. Thanks for joining on TikTok. You can tap the screen to give it some likes so the algorithm will send the video around. By the way, the Article 3 is the problems and Article 7 is the solutions. Now we have this wonderful video playlist links. So all of the solutions for Python are here. This is really great for passive learning. I'm telling you, I am a huge fan of active learning, and we know based on the scholarly literature, active learning is much more effective for recall per unit of invested time. But I also have to say, as a student, like right now, my brain is fried. And as a student, there are times where my brain is literally just fried. You know what I mean? And so the truth is like, I'm not going to do active learning at those points in time. So better than nothing is passive learning. So I'm not saying replace your active learning time with passive learning, but I am saying if you're laying on the couch, if you're just like kind of like napping, you can listen to some lo-fi or you can listen to the video playlist. I listen to it when I'm taking a shower too. I said it. I listen to LeetCode. I don't do this all the time. This is not like a life choice, but during my layoff era, we're listening to LeetCode in the shower, like every second we can get. That's in this economy, as they say. Okay, let's get into some code. Kata, for those who don't know, is a memorization-based approach. So we start with the basics and we go through it. It's a reference to martial arts. You'll do certain movements and they flow into each other so that you can develop a muscle memory. So analogically, we have a meta flow among the mental models. 2-sum is going to roll into 3-sum. Linked list cycle is going to roll into palindrome linked list. And so we do these over and over, and it's a memorization-based approach that allows us to easily remember the main patterns. That's the goal. That's what we're doing here. Okay, so beginning with 2-sum with the input array sorted, number 167. The array is already sorted in non-decreasing order. Find two numbers such they add up to a specific target. The index will be greater than or equal to 1. And within the length, we return the one-indexed indices as a list that will always be linked to. There will always be exactly one solution. We don't need to deal with the case of no possible solutions, the sad case, and we don't need to deal with the possibility of multiple solutions. We are required to use extra space. So under these conditions, given that the array is sorted, my mind goes to windows and pointers. That's the pattern of interest. So intuitively, we can use 2 pointers in constant memory. Spelled memory correctly, didn't I? We can use 2 pointers in constant memory. In the worst case, we need to check every number. So time complexity is O of n. Okay. So we'll initialize left to 0. Right will be the length of numbers minus 1. And we will just make sure that they don't crisscross, while left is less than right. This is crazy. My brain is like toggling between Python and JavaScript right now, like the syntax. Okay, so the current sum, let's write this in the Python snake case approach. So the current sum is going to be numbers left plus the right index of numbers. And then there are 3 possible cases. We can be above, below, or at. Okay. So we are above when the current sum is greater than the target. Thanks so much for joining. Feel free to tap the video, give it a like. And then the else case, we found a match and we want to return one indexed to length list. So we'll return Bathsheba, good to see you. Thank you for the likes. In this case, we'll return left plus 1, comma right plus 1. So when the current sum is less than the target, we want to bring the area under the curve, the sum within the window, up by moving the left pointer to the right. Okay. And when we want to reduce that window sum, we will move the right pointer to the left. Because it's low to high. So the right pointer is always pointing at the higher number. So by moving it to the left, we're decreasing the total sum. Does that make sense? Out of range. What did I do? I did something wrong. So the current sum is the left index of numbers plus the right index of numbers. That seems correct. You don't want to increase right, you want to decrease right. I think I said it properly out loud. I think I just wrote it incorrectly. Okay, so we're done with 2 sum. Let's move on to 3 sum. Given an integer array of numbers, return all of the triplets, I in nums, j in nums, k in nums, such that I, j, k are distinct and they sum to 0. Notice that here we are returning a triplet of values, not the indices. So we don't have any concern about one indexing. Abraham, welcome. Thanks for being here. If you're on TikTok, you can check my bio to see the YouTube or Twitch link and see the full screen. You can also sign up at laterally.io and join the Discord. If I don't see your question because I'm focused on leak coding, you can always ask me questions after the stream. For instance, I'll be doing a complimentary resume review for one person after the stream. That's not available for everybody. Can't be doing that all the time, but that's a flavor of some of the benefits that you can get from joining the server, whether it's me or someone else. Maybe you can have someone else review your resume. Okay, great. So the intuition here is that we can wrap an optimal 2 sum with an outer index. With a left to right index. This cos O of n squared. And means we must sort. Sorting is a non-binding time complexity of n log n. Memory complexity can be constant. We just need pointers. Okay. So first thing I'll do is I'll sort. Then I will have results be a set. Use a set to auto dedupe. Use a set to auto dedupe value triplets. Okay. And then we will have a outer left IDX. We'll initialize that to 0. We'll say while the outer left IDX is less than the length of nums, we will call toSum, and we will fast forward duplicates. Then we'll eventually return results. We call it the outer left because there will be an inner left in the toSum itself. Some people prefer to call this left and use the term middle in the toSum. I think that that's really confusing, and I think it breaks the mental model meta flow that we're trying to create with the kata. Because remember, in toSum, we called it left, and it was very simple. There was left and right. And so I think it's easier to take that core model and add an outer left rather than renaming and saying that now that other thing is left. I prefer to call this one the outer left, or sometimes I even call it the wrapper. But I actually prefer outer left more than wrapper because wrapper might be taken to be on either side. And this is going to deterministically always be a left to right indexing approach. The vibe with it? Okay. How do we call toSum? We'll add it on self. We'll pass nums, we'll pass results, we'll pass this outer left IDX. Does that give us enough information to determine the optimal toSum result? The answer is no. We need to give it a target. The target for the inner toSum is the outer complement. And so the complement is the opposite of the value at the outer index. And the reason for that is when I have the value at the outer index, I want to find whatever will add it to 0. We call that the complement. That's just the conventional name of that thing. Whatever will add it to 0. That gives us 0 across the triplet. So the complement is the opposite of the number at the outer index. So I call toSum. I'm biref appending results. Now I will fast forward. And I'll say while I'm in bounds. I don't want an out of boundary error. To check in bounds, I can just replicate that main while expression. So while I'm in bounds and my value is the same as the cached value. So this will be basically the reverse of the assignment expression. Notice that this is guaranteed to hit once by construction, but it may accidentally hit more than once, and that will be the fast forwarding that saves us a bunch of cycles. So as long as that index, we're incrementing it, and it's producing equivalent complements. So we're going to fast forward this. It's guaranteed to hit once, so I don't need an additional iterator. While I'm fast forwarding this, as long as the complement is identical, we can skip calling toSum. Now let's go make toSum. Let's make sure we get the argument order proper. Because it's on the same class, we need to give it self in Python. I copied the argument literal order, so that should be fine. The left on this toSum is the right window of the outer index. So we take the outer left index and add 1. And then the right is the same right, which is just the right set of the whole. So that will be length nums minus 1. And we'll say back to our normal two-sum condition. While left is to the left of right, should they ever crisscross, we know that that is our exit condition. We want to get the current sum. Here, I'll extract the values. So I'll say left val plus right val. And I want to extract them for two reasons. One is because I'm going to check the left value as a cache condition, similar to what I did with the complement. And the other is I'm going to duplicate the expression, so I like to extract it and label it for readability. And then there's a consistency concern, which is like, if I'm going to extract one of them, let's just extract both of them. Blaze is lurking. What up, gang? Thanks for being here. We got someone in from Twitch. I love when that happens. I think Twitch is my smallest following, so it's always a delight. By the way, if you're on TikTok, you can go over to YouTube or Twitch. Maybe you can be the second person at Twitch. Okay, so we have the above, the below, and the else condition. This would be the match found. Append results with ordered tuple. Okay, the tuple is guaranteed to be in order. I'll call this ordered tuple. And it's guaranteed to be in order because the outer left is always to the left of left. And then the right is always to the right of both of those. So it's guaranteed to be in order. I need to remember to store the value, not the indices in this ordered tuple. So the value of the outer left is the opposite of the complement, which here, did we label it target? We're using the term complement. Okay. Sometimes I call it target, so I double check that. So then there will be left value and right value. So there's the ordered tuple. And now I want to results dot append. No, it's going to be add. It's add or append. I think it's add. I really don't know. We'll see if I get an error. It's going to be one of those. We'll add this ordered tuple. And then we want to fast forward. Okay, so the way we do this is similar to the prior. Like we're fast forwarding outside of two-sum. Let's also fast forward within two-sum. Memorization versus problem solving. The answer is both. The answer is both. Memorization enables problem solving. You had to memorize your arithmetic table before you could understand algebraic solutions. And being able to recognize a pattern is a matter of memorization. I think for some people, this is a hard truth, and I don't really understand why. But if you ever have the experience where you immediately know what a pattern is, it's because you remember the pattern. It is a memorization game. Definitely, the pattern can be expressed in multiple ways. That's for sure. That's for sure. But you start memorizing the many ways it can be expressed. You start learning the many ways it can be expressed by remembering one. And so that's the idea of the elite code kata, is not that you will become the greatest engineer ever by memorization alone. Rather, you'll become a pretty darn good one by memorization alone, and it will unlock the ability to be even better. I think even people who preach the fundamentals approach, when you ask them what a fundamental is in the context of DSA and whiteboarding, the patterns are fundamental. They just are. So you at least have to remember those. The difference is that this is a concrete-driven fundamental approach versus this weird abstract-driven fundamental approach, which I think is just a contradiction in terms. So I want you to remember the pattern by binding it to a concrete problem and its concrete implementation. And then, yes, I want you to be able to extend it later, but we're starting with the basics. And the basics is not like reading about what a hash map is in theory, agnostic to language. A much better approach is the concreta, which is I will tell you what this pattern is in the concrete Python optima. And then if you learn it in JavaScript, and then if you learn it in Java, that's awesome. And you can abstract and you can realize, hey, a dictionary in Python and an object in JavaScript, they're really just hash maps. That's beautiful. But you can see that I'm taking the concrete step first, as opposed to leading with abstracto, which I think is the wrong approach to learning. That was a fun tangent. Thanks for the question, or the comment, rather. I guess I took it as a question, but maybe it wasn't. I'm not sure. Anyway, thanks for being here. So while we have duplicates, duplicate of what? Duplicate on the value. Duplicate on the value of left value. So while left value is it NUMS or numbers? NUMS left. So while this value is being produced by this index on the set, we will increment this index on the set. So we're moving left, left, left to skip a bunch of cycles, but we don't want to go out of bounds. So we need to have our boundary condition, and that's going to be, in this context, left being less than right. I misspoke, but I think it was still correct. Left being left of right. Thank you for the likes. Quick reminder, you can go to YouTube or Twitch in the bio to see the full screen. Okay, so we have a boundary condition, and then we have our stale revalidation or our cache checking. Okay, so this block looks good to me. These blocks are not quite right. So the above condition is cur sum is greater than target. The target here being the complement. And then the inverse. When the current sum is above, we want to bring it down. We bring it down by moving the right hand to the left. And the inverse is to move the left hand up. Solution has no object called toSum. This is a famous Python indentation problem, I think. Okay. Love it. Okay, so we have solved 3-sum. Now we are on to longest substring without repeating characters. Oof, what a fun one. How did you learn how to do this? Was it projects? No. I learned the basics of coding and syntax through projects. Then when it came time to do LeetCode, I took a systematic, basically what I did is I scanned the questions that my target companies were asking, and I did a ton of research is what I did. You can read the LeetCode article. So prior to the LeetCode kata, it gives you the overview of the research. There's a long history of these whiteboard preparation approaches. So I do stand on the shoulders of giants to an extent. So I wrote the 5 to 23 patterns article years ago. This builds on Sean Prashad's 14 patterns, to which I contributed, by the way. So I pull requested his repository. He accepted it. But basically, you can scan all of the LeetCode corpus, and there are 23 identifiable patterns there. So Prashad would tell you that there's 14. I would tell you that there's actually 23. And frankly, there's some problems that fall out of those 23. They're just like super rarely asked and really weird. So no one cares. So among these 23 problems, how do we focus it down? Do you just learn all of the LeetCode? That's really difficult. The prioritization criteria is what are the employers asking for? That's where I bring my value. So I have a PhD in economics where I studied attitudinal trends among employers with respect to post-secondary alternative credentials such as certifications and coding boot camps. And I said, what do employers like? What do employers like? And so one of the answers to that is crystallized in my LeetCode kata, where I do a coverage metric of these problems. So here's the historical guidance. There was the blind 75, 14 patterns kind of superseded that. NeetCode, love NeetCode. And then I build on these. to provide this. And I have a percentage of coverage. Let's see, is it in this article? Yeah. The laterally expanded kata. What about the non-expanded kata? What about the standard kata? Well, anyway, let's go with the expanded kata. That's fine. So the expanded kata is 20 problems. The standard kata is 12. But the expanded kata conservatively covers about 73% of expected interview questions in big tech whiteboard coding rounds. Think about how impressive that is. And you should immediately be asking, where is the research basis for that? Where's the research basis for that? That's like a really surprising claim. The research basis is this algo monster statistics. And yeah, the way it works is just like literally data mining. Where's the study data? Is it LeetCode itself? Go away, little thing. Facebook, Google, Expedia, Airbnb. I think these are coming from LeetCode, if I'm not mistaken. I guess I'd have to read around the website to confirm, but I believe this is like a snapshot based on LeetCode. LeetCode will tell you, like, these are the questions asked at Facebook. These are the questions asked at Google, and so on. Let's see if I can quickly show that. So you see here, Amazon Spring 23 high frequency. This is for 2023, but there is also like just a general Amazon list that's not specific to 2023. Yeah, so here you see the labels and the frequency metrics over here. So we're saying, what are the most frequently asked questions? That's how we prioritize particular questions and patterns. Okay. This is the realist version of coding, 100 GitHub tabs open and reading an old article. Gang. All right, let's get back to it. Longest substring without repeating characters. Given a string S, let's find the length of the longest substring without repeating characters. Is it possible to get an empty string? The constraints are that S might be as low as 0. So it's possible to get an empty string. We need to think about this edge case. English letters, digits, symbols, and spaces. And we'll be returning an integer. Okay. So intuition, the S might have no repeaters. So in the worst case, solution is length n such that is length n such that n is len s. So in the worst case, time complexity is O of n, scanning each letter, and space complexity is also O of n, or is O of n minus 1, which asymptotically approaches O of n, because I need to remember potentially all characters except the last one. to identify uniqueness. Does that make sense? So I need to remember all the characters that I've seen. And in the worst case, I might need to store every character except the very last one so that I can make sure it's not duplicate of any of the others. So that would be O of n minus 1, which is asymptotically O of n. So how do we do this? So the max char length is initially 0 and will eventually return the max char length. Okay. We'll do while foo, while something. And in this while something block, we're going to recalculate the maximum length is the maximum of whatever it was previously and the current substring length. So that means we need to define the current substring length. Well, that's going to be the right of a sliding window minus the left plus 1. So let's use a sliding window. Let's use a right led sliding window and adjust left pointer if I see a dupe on left, or if I see a dupe on right. Ooh, that's a tricky bit. If I see I'm leading with my right, so if I see a dupe on right, I need to adjust left. That's the tricky bit. I mean, I guess there's a few tricky bits of this problem, but for me, that's the tricky one to remember. I see the dupe on right, I don't eliminate right. I eliminate left because I can't, if I eliminate right and then I move right again, I'm just like never ending, right? So I need to, I ran into a duplicate and I need to shrink the tail. Did that make sense? In my brain, that's the hardest part to remember. Okay, adjust left pointer if I see a dupe on right. So my current character is right of S. Now, where is right coming from? Well, that is how we remember our while condition. And it won't be, you could do an external index and iterate it for a while, but you can also just do a for in range. So for right in range length S. Does that make sense? How we're going right led, it's iterating on right. That's what I mean by right led. By the way, if you're enjoying the video, give it a like, follow the page on whatever platform you're viewing from. Thanks for being here. Feel free to drop a comment as well if you have any questions. Okay, so for right in range length S, I have the current character. Maybe it's an A or a B. And then the question is going to be, is this a duplicate? Rather while it's a dupe, let's handle left. I'll put it to do there. But notice that we need a new structure here. This is the cache that I talked about, but we never implemented. So if it's a duplicate, the way I know that is because the current character is in a collection of things I've already seen. You could do this in a variety of ways. You could do a list, an array, a hash map, a set. I'm going to go for the set because it constrains the memory. So think about a key value pair and a hash map. You don't really need the key value pair. It's just extraneous memory. So the set is sort of the minimal Boolean indicator of a collection. It's the minimal Boolean indicator. Does that make sense? It's like I've seen it. That's all it's going to tell you. I've seen it. You might ask, like, why is it good enough to know that I have seen it? Don't I need to know where I have seen it? And the answer is actually no. We actually don't care where we've seen it. If I've seen it at all, I need to purge. If I've seen it 1 space away or 10 spaces away, I need to purge regardless. Okay, so while current character in scene, the first thing we do is we purge it. So now we say that scene.remove cur character. Oop, I got something wrong on my clipboard. Cur character.remove cur. I said that wrong. Scene.remove cur character. Let's make sure we're doing the inverse. If I'm removing it, did I ever add it? No. So here I want to scene.add. Okay. So after I assure that there are no duplicates in my substring, after that, I will then store and calculate. Do you see why that's proper? I want to first purge the duplicates, then store the current character and calculate my substring length, my current substring length. Because only at this point is it valid, a valid substring. Great. Now that I've removed the character from the scene set, what do I want to do? I need to handle left. So left, we will just increase it. Is that good enough? No, it's not good enough. It's not good enough. I'm forgetting something here. I think I need to purge left. I don't purge the current character. I need to purge left until it does purge right. Because I'm moving my little left, moving my little left. That still seems wrong. What if I have 3 C's, but I should never have 3 C's? Because the second C, I'll purge the first C. So I'll never have a situation where left is moving along a series. So it's fine to purge on left. Okay, so this is S, left. Right is a dupe. Let's purge left until purging left does purge right. Does that make sense? That's the uniqueness condition. So we're going to move left. Let's say I have like A, B, A, B. I'm going to move my left until the second B has, until the first B has been removed, so that the second B, where my right hand is now unique. So by purging left, I have purged right because they're both on B. So let's purge left until purging left does purge right, i.e. generate uniqueness. i.e. generate uniqueness on right. Okay. This seems fair. Let's try it out. Cannot access left where it's not associated with a value. That's a problem. Right. So let me go initialize. There's the max character length. Left is going to be initialized to 0. Now we can't access max char length. Did I misspell something? Max char length. Oh, yeah. It's spelled differently. Okay. Voila. There we have it. The tricky bit for me is always this purging logic. We encounter a dupe on right, so we need to purge from left. Is really counterintuitive to me. Okay. We are up to the about 40-minute mark, and this is the 4th problem in the kata that we just completed. So we did 2 sum, we did 3 sum. This is the expanded kata. In the expanded kata, you do 3 sum and 3 sum closest, which involves binary search. We're not going to do that today. I would fry my brain. Okay. We're in the standard kata. I do want to know, what is the percent coverage on the standard kata? So here's the algo monster estimated coverage. The labeled region of the pie chart here is only 78%. So if you master 15 patterns, and some of these patterns are responsible for less than 1% of problems, but if you master these 15 patterns, you still have a 20% chance of getting a problem you've not seen before. So there is a lot of random variation. in these like whiteboard interviewing rounds at big tech. That's just how it is. That's why you shouldn't bank on a particular company. I encourage you to apply to an industry, apply to fintechs, apply to cloud, apply to health, apply to FANG, apply to big tech. Don't just apply to Google. As a statistical matter, you're unlikely to pass Google on your first try. And if you're really, really stuck on Google and you're like, I'm going to get into Google, whatever it takes, I'll do it over and over again. The cooldown could be like 6 to 18 months. Check with your recruiter. If you're borderline, they might give you 0 cooldown, which is really cool. Sometimes you can get that. Just ask your recruiter. But generally, it's like 6 to 12 months, sometimes 18. And so think about that. You're like, I'm only going to Google. And like each time that you apply, you probably don't get in. And this is coming from someone who's gotten a Google offer. I've gotten a Google offer. But these are like independent trials, and any particular trial, you're unlikely to get in. So you're going to need to do like 3 or 4 tries. You can probably get in after like 3 or 4 tries if you keep practicing. I mean, maybe that's like the silver lining, the good news. But 3 or 4 tries could be 3 or 4 years. Some people will hear that and they'll go, that's fine. I'll try to get into Google for 3 or 4 years. Power to you. I would say, while you try to get into Google, why not hang out at Meta instead of, where are you? Are you even employed? Tier 2 company, no job at all. Tier 3 company. So I think it's perfectly fine to try to get into Google for years. I think that's a great goal. But what are you doing in the meantime? That's the reason I think you should apply to like big tech or fintechs or whatever. Like, in the meantime, I'm at a fintech. That's what I did. Or in the meantime, I'm at Meta or Insta or Snap or whatever. Because there's a big opportunity cost to that meantime. There is a wrong answer here. The wrong answer is, in the meantime, I'm unemployed. That's not a good answer. As an economist, we know that utility is subjective. I'm sure for some extremely unusual indifference curves, you could construct a personality which would be content to be totally unemployed and then only go to Google after 4 years. Fine. For the market of job seekers, that is not optimal. At the median, at the average, at the P99. So yeah, you can contrive some like strange personality type that may or may not actually exist. I would love to meet such a person. This market is tough. I hear you, but the right practices will solve it. The right practices will crack a tough market. I got laid off a week ago and I had my first interview this morning. Is that absurd? It feels absurd, but it's doable. It's doable because there are research-based practices that can differentiate you from the mean median mode and put you not just into the top, 50%, 75%, but put you into the top 10, 5, 1%. The market is tough on average. It's particularly tough for juniors right now. I really empathize with that. I teach some juniors. I'm trying to help them. It's tough. Even me helping them, it's still tough. But if you can get into the top 1%, it's really not that tough. It'll be tough to get, a $500K a year job. That's going to be tough even if you're in the top 1%. But a 6-figure job in the top 1%, hot take here, it's really not tough. Hot take here, it's really not tough. If you're willing to accept 6-figure as low as like 100K, I don't think that's tough for a top 1% programmer. Okay, that was a fun rant. What are we doing? We completed the longest substring, so we're continuing with linked list cycle. Here we go. I couldn't find the percentage coverage, but it's going to be less than. That's what I was doing where I got sidetracked, the coverage percentage. 4% less coverage. So it's very close to, okay. Part of me was like, should I be doing my own expanded kata? Because like, if the expanded kata is getting to 73 and I'm dropping 8 problems, am I dropping under like 50%? You don't want to be under 50%. What you want to do is be in a situation where you can genuinely say, for this coding round, I will probably pass at the micro level. This coding round, I expect to pass. If you can genuinely say that on the basis of research and data, that is a huge like cognitive boost, like placebo, all the way motivation, dub. And the way you do that is you need a research-based number that says coverage is over 50%. That's the key. So I'll be at like 69%. I'm still over 2/3, which is like powerfully over 50%. So skipping DP, I'm very happy to skip DP. Divide and conquer is like adjacent to DP. And bit manipulation, I don't want bit manipulation. Get out of here. Get out of here. It's such a poor use of your time. If you get a bit manipulation question, like, tell your recruiter, like, what's going on, dude? That's ridiculous. So yeah, 68 and change. It looks like 68.6 rounding to 69. 69% coverage out of 12 problems. Fantastic ROI. Ali G, welcome. Ali G says, I've been getting leak code hard. Yeah, the leak code kata goes through hard. The leak code kata goes through hard. Is word search hard or word search 2? Word search is medium. Yeah, word search 2 is hard. Tree level, I don't think this one's hard, is it? Yeah, that's medium. What do we have in the standard kata that's hard? Pathsum 2? Still medium. Pathsum 2 is a medium? Oof. Not all mediums are created equal, huh? What about the one I'm about to do? This is considered easy. I guess the standard kata doesn't have any hards. Is that true? I don't know if that's another benefit or a curse. So if you want some hards, you can go for the expanded kata. But I will tell you, if you can unlock the patterns, the fact that it's hard merely means that it's going to take longer. If you can understand the patterns, it's actually not a big deal that it's hard, except that you can see that, oh, this hard problem is like a combination of these 3 different patterns. And it's problematic in the sense that you're going to have to write a bunch of code and untangle those. It's going to take you a while. But conceptually, if the hard is composed of the common patterns and the common patterns are covered, you stand a very good chance, I would say. You stand a very good chance. It does complicate things, though. Sharp Dev Trev, welcome. Is Code Forces a good measure of one's ability? I'm thinking about going for a master title on Code Forces. I have no data to suggest nor to reject that a master title on Code Forces is significantly associated with placement at a big tech company. I have no data along those lines. What I can tell you is this. If you practice the laterally leak code kata, you can cover the vast majority of questions you will be asked. So this is the evidence-based, research-based approach. If you run into an academic study or any research that says Code Forces makes you pass and get placed, send it to me. I'd love to read it. All right, I've been sidetracked for a bit there. Good chat, y'all. Thanks for the comments. So let's open up. We already did this one. Let's close that. We're doing the linked list cycle. Okay. Given the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Did they just give you the answer? There is a cycle in a linked list if there's some node in the list that can be reached again by continuously following the next pointer. Okay, that's not giving away the answer, but it sounds very close to the answer. If you're thinking of a fast and slow pointer approach, which is optimal. Okay. Internally, pos for position is used to denote the index of the node that tail's next pointer connects to. It is not passed as a parameter. Okay. Return true if there is a cycle, otherwise return false. In example 1, we see an illustration of a cycle. Basically, it's an infinite loop. So if I just traverse the list, if I run into a terminal node, there's not a cycle. I'm not really interested in Fang jobs, so I'm not sure if I'm studying properly. Feel free to join the Discord. You can join ladderly.io. Join the Discord under the community tab. You can book a consult. We can do like a custom research, like custom study plan for you. It's going to depend on what your goals are. But if I don't know what your goals are, then, what are we optimizing for? I'm in the Discord under another handle. That's great to hear. I'm glad you're over there. Yeah, so feel free to DM me or let me know. Maybe I'll schedule a session. Sure, yeah. Or you can DM me. If I have time, I'll answer. If I don't have time, the formal way to get on my calendar is to book a session. Okay. Yeah, and if money's tough or something like that, shoot me a DM and I'll try to find a coupon or some spare time. We'll figure it out. But basically, I need to know your optimization criteria. Otherwise, I can't give you any advice, right? Well, I can. I mean, if your goal is not to work at Fang, just play Smash Bros, dude. Just hang out at the house, That's what I'm going to be doing later because my brain is deteriorating. The fact that I can't focus is the most appropriate evidence for you of how fried my brain is right now. Let's do a cycle thing. Okay. Given head, right. So we want to not have an infinite loop. So intuitively, if I ever terminate, I don't have a cycle. If I never terminate, how can I catch it? The obvious approach is caching scene nodes. This takes O of n space complexity. However, I don't need that because a lagged pointer can also indicate cycle by collision. That uses constant memory. Either approach scans all nodes in all cases, worst or best case. So time complexity is O of n. Did that make sense? Let me know if you have a question in that. So we're going to use a lagged pointer. This is also called a fast and slow pointer. This is a special form of the two pointers method. There's also a name for it. I don't know, the people who originally came up with it, the researchers. Siddharth, welcome. What to study after DSA, like AI, ML, web development, or Android or data analysis? I don't like any of those. I don't like any of those after DSA because I think that you should study web development before DSA. I don't think that you should learn to program through DSA. I think learning in abstracta is the wrong approach for learning. We'll have better retention, better recall, better long-term career prospects, better job placement, win-win-win when you take a project-based learning approach. So check out ladderly.io. You can sign up for free. There's a standard checklist that's made available to you for free, and it walks you through step-by-step my recommended approach to help you learn to code and land your first or next programming role. It is a project-based approach. There's the big 4 projects. Only after you have built the big 4 projects do you start studying the LeetCode. Leak code is not even required. Leak code is not even required. Leak code will unlock tier 1 companies, but it's not required to get a programming role, and it's not required to become a senior, and it's not required to get a 6-figure remote job. It is not required for any of these things. It will be required if you want a job at Google. It will be required if you want a job at Meta. You will need to have the traditional whiteboard style coding round. They just haven't shirked the garment yet. What is the Big Four projects? Basically a blog and a capstone. So you will do a vanilla HTML blog. Then you will do a next local storage blog. Then you will do a full stack blog with a SQL database, PostgreSQL database. And then you will do a capstone. So the blog, 3 blogs is a pet project pattern. This allows you to focus on learning semantics and technologies and avoid wasting time relearning business cases that are irrelevant to you. So they hold the domain problem constant and allow you to focus on learning the technology. That's why this is a really efficient learning approach. Blog. In each of those cases, it's not a cookie cutter blog. It's a blog tailored to you. You'll be blogging your actual things that you're learning, things that you care about. I had one student who made like a blog about cookies, like all sorts of cookies recipes and things like that. I love it. The style of the blog, the theme, you should be choosing your favorite colors. This is all included. So it'll be very uniquely you. It's not going to be cookie cutter. And yet the project is incredibly recognizable, because what's more recognizable than a blog? Everyone knows what this is. When you interview with the employer and they ask you what you've built and you say a blog, they know what you're talking about. It's not strange. It's easy to communicate. They may say, oh, poo, like this is very boring. But then you can push back and say, well, it's not boring because it wasn't a cookie cutter blog. I did A, B, and C that are unique to me. It expresses my personality, my background. And beyond the blog, I did my own capstone. Then there's like your actual portfolio, which is just really one page. I don't even really count it. It's just a page that links to your other projects. I'll show you mine. This is my portfolio page. This is it. You don't really need this. You can send people your GitHub landing page. That's fine too. But you see, like, this will take you to some projects demonstrating various things. Change the color of the turkey. Yeah, so I encourage you, come by the this one's optional. You can just send people to your GitHub itself and use this styled README. Please do use the profile README. It makes a difference. I hate writing. I'll try to schedule something this Wednesday if you are available. Sorry to talk while you're on stream. Yeah, I'll check my calendar. Nothing off the head, like nothing is coming to mind immediately, but let's double check, because there could totally be something scheduled and I'm just not thinking of it. Okay. So we're going to do the lagged pointer or the 2-pointer approach, fast and slow pointers. So what I want to do is I want to say while there's a node, while right node. So left node is head dot is just head, and then right node is head. One thing we want to do is make sure that these exist. I think I can do that internal to the while loop. We can also guard on it. We'll guard on it. So if not head, return. So if there's not a head, then it's not a cycle. And if it's not a cycle, we want to return false. So if not head, return false. I think you're guaranteed to have head though. Yeah, so I don't know that I need to do that, but whatever. And in like the real world, that would be a nice safety measure. Okay, so now that I'm guaranteed to have head, I'm going to set left and right both to them. They're going to point at the same place. The location is not the variation of fast and slow, the progress rate. It's the fact that they're dynamically different that allows them to collide, which shows that there is a cycle. So with fast and slow pointers, it's different than the ordinary. It's different than a window. It's not a window. Fast and slow pointers are not a window. The window and the fast and slow pointers are two different dichotomies of the multi-pointer method. Okay. So while we have a right node, if right node dot next, and right node dot next, then right node is right node dot next. So you see how it's moving twice. It's going to be moving twice while the slow one moves only once. So that's how we get the dynamic variation. And what about the else condition? Else return false. The list terminated. Okay. Now, if right can move twice, definitely left can move once. So we don't actually need to do any null checking on left because it's always going to lag right. So left node just is left node dot next. So as long as we have a right node, that will take care of things. And then if we run into a situation where we don't have a right node, for safety, it means the list terminated, practically extraneous, because this check is duplicated within loop. Okay. It's taking a long time. I wonder if I'm timing out. All right, let's see. Got a TLE. So what did I do wrong here? So I have the head node, while right node, if the right node can proceed once, and it can proceed twice, then we will set it to the grandchild. Oh, I didn't return in the case where they collide. So this is like a unary Boolean. That's not good. So what I need to do is so I've incremented right and left. After incrementing them both, if they are the same referent, now we return true. There was a collision. There's a collision, so there's a cycle. Okay, great. This has been a good session. Even though I've made, I think, one mistake for every problem, like even the most basic problem, but the mistakes were like very simple fixes. Okay. Now for the problem of the day. So up till now, these are repeat. Okay, and my wife is calling me. Let's see how much trouble I get if I decline her. One moment, I'm going to text her. Okay. If she yells at me, I have to end the stream. Quick, let's detect a palindrome before my wife yells at me. So up till now, we are repeating problems that we've done so far. The palindrome is the new one that I haven't done since I started my job search. Okay, so let's read it. Allegedly, it's easy. We'll see. Given the head of a singly linked list, good to know that it's single. Return true if it is a palindrome or false otherwise. Notice that true and false are lowercase. What is this, JavaScript? If it's a palindrome, and then we know what a palindrome is, ABA, race car is a famous one, dad, mom. 1221, when it's turned into a list, is a palindromic list. And this actually sort of gives away one solution. One solution is cast your linked list to an array, and then you can take 2 pointers and inspect the array. And if they're similar until they collide, that's a palindrome. So take a 2 pointers approach with a full window. Dad, they are same, they collide, they are same, then they're fully similar to the point of collision, it's a palindrome. So that's the way that you classically detect a palindrome on like a string or an array-like structure. And you might think, well, a linked list is an array-like structure. No, this is a singly linked list. It's like a distant cousin of an array, but you can't initialize to the right of a singly linked list. You can't do that in constant time. To get to the right of the singly linked list, you have to traverse the list, which is fundamentally, we talk about fundamentals, that's fundamentally different. So it should make us consider, well, okay, we can do that, but is that optimal? Casting to a list. Is casting to a list optimal? Why would it not be optimal? Because I have duplicate data. I have the representation of the linked list, and I have a duplicate representation of the array. So it's an O of n time complexity. So here we say a brute force solution is to cast to an array. This costs O n space complexity. Then classically check similarity between left and right pointers. This takes O2n, or asymptotically O of n, time complexity. So it's a 2-pass solution. You're passing to cast list, and then you're passing to verify similarity. But I think we can do better. How to do better? Something 2 pointers. So what I would like to do is have a pointer chilling at home, and then a pointer go to the middle, and then I can check similarity, progress from there. The problem is, how do I know? So this would basically be fast and slow. So if I have fast and slow, how do I know to trigger the slow one to start? I'm looking at this singly linked list. It doesn't have any metadata. It's not like a singly linked list with the length. If it had the length on it, I could progress my first cursor, and then I could, whenever I get to like the length divided by 2, I could like start the second one. That would be really, really cool. And that would be like a singly linked list if it also had self.length. But we don't have that. So I can't. So I can't do this without, at least not that I know how, I can't do this without scanning the whole list. More than once. But it's still, so I think it's still a 2-pass solution. I think we need to scan it twice. But because I can basically recombine the list as I scan it. I can like, whenever I go to the next one, I can like point back to the last one. That might sound really stupid if you don't know what I'm trying to say. um, do I need to copy the list? I think I should be able to do this O of n. Target performance is O of n asymptotically. Target space complexity is constant, 2 pointers. Left is 0, right is 0. So, and then I want to return is palindrome. We will default this to false. And then we will only return true if we find one. And what I want to do is like recombine the second half of the list somehow. How do you say that? Like re-network, re-point, re-stitch the second half of the list somehow. Then compare list halves with the 2 pointers. Oh, can I make it doubly linked? So it's singly linked. Can I just, does it have to stay singly linked, or can I make it doubly linked? Yeah, so I don't need to break the forward links if I can just add backlinks. I don't know if I'm allowed to do this, but I guess I can try it and then it'll tell me if I cannot. Yeah, it's not in the type. It's not in the type, so I think I cannot. Because if I add dot back, like if I create that, then I'm basically breaking the type. So if I did it in a pure way, I would need to create a new object that has such a property, which is effectively doing the O of n memory problem. Let's see. I'll time box this to maybe 5 more minutes and look up the solution. So this is easy, huh? It's so easy. Maybe it's easy because they're thinking that you're going to do the list thing. Yeah, that would be easy. That would be easy. I don't want to do it though. So this, how do I know that I am at the second half if I can't navigate backwards? It's guaranteed to be terminal, right? There's not a cycle in this. The number of nodes in the list is whatever. Yeah, if it can self loop, if next, I'm assuming that cannot be the case just because it's an easy. Like if it's an easy, then I don't expect self loops. That would not be easy. Maybe my judgment there is off. Okay, so let's assume that there are no self loops. So I could just have some external counter that is still constant, but it's like an integer counter. So I scan through the thing, and now I know the length. Okay, so it's basically like a multi-pass solution. So length is 0 while right. Sorry, while first pass node. So first pass node is head, while first pass node equals first pass node dot next. And we are just found length of list. So we're just finding the length of this list. Okay, so now I have the length of the list. Midpoint is the found length of the list divided by 2 and rounded. So that double division in Python is the floor math. In JavaScript, it would be like math.floor. Okay, so now I have the midpoint. So this didn't cost me any memory. It just cost me performance. So this is like it's like a 2 or 3 pass. So it could be linearly slower. This could be linearly slower than the brute force, but it's no memory, which makes me feel cool. Okay. So now that I know the midpoint, what I want to do is mutator node is also head. So I can only change next is what I'm thinking, right? Yeah. Because we're going to retain singly linked. So I can only change next, but I only want to do that after the midpoint. So while mutator node, let me get rid of these parentheses. So while mutator node, if cur idx is greater than or equal to midpoint, so now I need a cur idx. Cur idx we initialize to 0. So this is where we're currently at. Do mutation, else just navigate for now. So mutator node is mutator node dot next, and in this case, mutator node is mutator node dot next and repoint. Now I need to repoint. I can't do it like that. So future mutator node is mutator node dot next. So this is what you're going to be. And you are going to point at what you are right now. So that's like causing the reversal. So this is the repointing on next. Does that make sense? So what you're going to be, I think I need to do that. I think I need to do that later because otherwise I might go in a circle. I did it in one pass. I don't want to throw off your thinking though. Thanks, SharpDev. Okay, if future mutator node, so my mutator node has its next, which is a node. It's a different node. And that one I'm going to set at current. That's fine. But I only want to do that after the navigation has taken place. I'm not sure about that last part. Darn. Not sure about that last part. Let's see, I'll give this 2 more minutes and then I'll time box it if I'm not making progress. So I'm getting stuck on this reference reversal. So while I have a mutator node, I'm just going to navigate until we get to the midpoint. Once I'm at the midpoint, Oh, maybe I'm doing this backwards. Maybe I want the slow node to go with the mutator to the midpoint, and then the mutator keeps going and the slow node goes backwards. So maybe I want to be doing the next repointing from the beginning. Then it would just be a 2-pass. That's better than a 3-pass. And then it wouldn't be linearly slower than brute force. Okay, so let's say I'm doing the repointing from the beginning. I mean, that's just a matter of flipping these bad boys. So if current index is less than midpoint, do mutation, else just navigate, and navigate mutator and nope, I don't know if I can do that. So in a situation where it's like race car, I'm at the C, the mutator is going forward. Yeah, that's okay, as long as, but how do I make the other one go backwards? That's the tricky part. Okay, I'm going to check out the solution. Oof. Python easy. Stack, it's a stack reverse. Nah, that's the array. I mean, fine, but that's not what I'm looking for. Maybe I'm going to need to do a special Google for this. I think it's on my playlist. So we go to the laterally leak code kata. We're going to article 7, solutions in Python. We'll look for palindrome. Palindrome linked list. Looks like I have 2 different solution videos on this. Let's check out the neat code. Skip over to the end. Find middle. Okay. Okay, so he finds middle in 1 pass because he's using a slow pointer. Neat code is the goat. Okay, fine, but then what do you do from there? So your fast one is moving into the end, and when your fast one hits the end, your slow one is at the middle. So your slow one is at the middle. Temp slow. Okay, so this is what I was trying to do, but how did he do this? He called it temp. So temp is slow.next. I called that like future. This is still a 2-pass. Okay, so it's actually the same solution. He just did it better. Yeah, sharp dev trev. Drop the 1-pass solution if you have it. You can go ahead and drop it in the chat since I'm like looking at the solution now anyway. Or I don't know if you're like on your phone, if that's hard to do. But yeah, I'd be curious to see how you do this in 1-pass. Rook and Pawn says, hey, I'm inspired to join you with nonstop leak code. Let's go. Welcome, welcome. Hope you'll pull up to the Discord. You can let us know your like daily or weekly progress or whatever. Let me know if you want to do a stream as well sometime. No pressure, right? I know some people are camera shy. That's totally fine. But the accountability partner aspect of joining the community is like a super potent motivator for a lot of people. Particularly if you're saying that you're inspired, then you might be disproportionately affectable by social pressure, basically. Was that Uber for 4+ years? Go, Node, Infra. Sheesh. Go is some cool stuff. I'm not pro with Go. All right, let me try and comprehend this solution here. Okay, so he wrote it so simply to use this reversal that I couldn't do. Let me bring mine on screen so I can break the difference. So he's using fast and slow to find the midpoint. Like, why, bro? Is that better than just the found length? That actually, yeah, I'm not understanding. I'm not understanding why to do that. Maybe it saves you a pass because he's going to put slow to the middle and then he's going to reverse. Left, right is head and priv. Okay, it's this priv thing. Yeah, okay, this is why he does that. This priv thing is the piece I was missing. So he goes fast and slow, and then his slow pointer becomes priv. That's wicked. And then it speeds up. So his slow pointer becomes a reverse fast pointer. Or maybe his secondary maybe his left pointer is also slow is a good way to say it. They are synchronously timed. While head and head dot next, s plus head value is head next return s. Yeah, so you stringify the array. So that is the O of n memory solution. Okay. Also, that is that O of n? I don't know if you can do that in constant time in Python. So you're leaving it as, yeah, like I don't know what Python does under the hood when you compare strings. Is it constant? I guess it's hashing, right? It's not like iterating through the strings. So I guess the comparator would be constant time. Yeah, I think that's fine. I don't really care if you call that 1 or 2 pass, but you're using memory there, which I was trying to avoid. Okay, so we reverse the second half, and this is the weird part. Slow becomes priv. So this is the part that I'm not getting. I mean, I get it now, but I didn't think of it. I guess it's easy enough to remember that slow becomes priv. Slow becomes priv. If you can remember that, you can remember how to reverse it. So let's try to write it out. Temp is slow dot next, then slow dot next is priv. Right, so priv starts as none. How does last run into the none? While right. Whoa, slow becomes priv becomes right. This is like the anamorph of pointers, dude. Slow. This is fine for leak code, but in production code, I would really hate this. So you're relabeling your pointer and then you're using it for all these different use cases. All right. But I get that it's like really efficient. So priv is none, while slow. So this is the second half of the linked list. Slow is going down all the way till none. And at the end, At the end, slow is none. So slow does drop off. Slow does drop off and become assigned to none. Priv is like a lagged slow. Priv is slow. Yeah, so priv is a lagged slow. So priv never gets set to none. That's a second important note. So slow is going to fully traverse the list. Priv doesn't fully traverse the list. It traverses it to the last node and it doesn't progress to none. So that's why we can reuse priv. It's still populated. So temp is slow.next. So there's like two new variables here. There's priv and temp. Priv and temp. Oh, he misspelled temp one of those times. Look at that. There's priv and temp. So temp is going to be slow.next. Yeah, that's going to be hard for me to remember, but if I practice it a few times, I'll get it. So basically there's priv and temp, and priv, temp, and slow, and priv is the lagged slow. All right, let's see if I can do it. There's priv, temp, and slow. Where is... Did I lose my late code? Where did my little window go? Maybe I closed it or something. That's fine. We will open it back. Okay, so here we are. So left and right, I don't want left and right. What I want is a fast pointer and a slow pointer. Slow, so later we have priv, temp, and slow. Priv is a lagged slow. Slow drops off and points to none before priv is used to determine palindromicity. I don't like that word. That feels like an unnecessarily long word. Okay, so basically I want to get rid of my whole implementation. That's all wrong. That feels great. So while fast node, I'm going to call it fast node. For whatever reason, like slow, I understand is a node. But fast, I want to call it fast node. Okay, so fast node equals so if I'm able to step forward twice, then fast node will step forward twice. Else like nothing. So if fast node can step forward twice, then slow will step forward once. Okay? So now slow is at midpoint by the time we exit that loop. So while slow, temp equals slow.next. Priv equals temp. Is this right? Priv equals temp. We need to initialize priv at none. Priv equals temp. Oh, okay, hold on. Slow.next equals priv. So this is how my initial slow, when I'm at the midpoint, I can have it point to none, because my slow.next is priv. Then priv is temp. So that skips me ahead of the broken reversal. But I do feel that I'm missing a step. So what is slow now? So slow.next is priv. Then priv is temp. So slow equals slow.next. Is that right? Okay, let's see what LeetCode said, or what NeetCode said. Is this the right thing? Temp is slow.next. Slow.next is priv. Priv is slow. And slow is temp. Priv is slow. So priv.next does point to none. That's right. Priv.next does point to none. So priv.next is properly none. Continue without crashing into none. Eddie, thanks for the likes. So this allows slow to continue to the next iteration, okay? And it'll continue until it is none, and then it's gone. So now I've reversed the second half, and now I want to have left, right equal. So left is going to be the new head, and right is going to be at the midpoint, or heading towards the midpoint. So right is going to be slow. While either one of them, you could say while left. So how do I continue? Left. If left dot value, it's just val. If left dot val is not equal to right dot val, not a palindrome. Else, join the premium subscription, but it doesn't appear anything happened. Not sure where you are with your integration. Yeah, I have to update it by hand nightly. It's not automated. I need to fix that, I know. Thanks for the subscription. I'll take care of it tonight. So you should be able to access the advanced checklist and stuff like that starting tomorrow. Okay, so if the left value is not the right value, now they're like heading towards the midpoint, and then it's not a palindrome. Otherwise, that doesn't mean that it is a palindrome. It means we should continue. Else, left is left.next, right is right.next. And eventually they'll run into none. And when they run into none, the while loop will break. And we can return true. That will be a palindrome. Ooh, maybe this needs to be right. Let's see. Let me break this apart. Left is head, right is slow. So if right is slow, and if my mutation worked, then we shouldn't TLE. This should guarantee to run into none. So there shouldn't be a loop. So my loop is up here, I think. It's like never exiting this while. So why would that be the case? Because there could be an odd number. So let's say there are 4. Then right has next, dot next, only once. And what should be the case? So slow moves up once, and that's okay. And that's okay. We don't need to increment slow again. So fast node is fast node dot next, and slow is slow dot next. And then if fast node has a next, we use it. None type object, okay. Maybe I should say if fast node. Okay. All right, so that took care of the timing out there, but something is still wrong. Let's see. Bro, you got to lock in. Thanks. Thanks for the tip. Output was true when we expected false. Wow, so they got down here with different letters?
Hello?
Hey, I'm streaming. So let's see what the difference is. All right. Neat code, where are you at? So left right is head priv. Oh. Left, right, head. Okay, so I said right is slow. I should have said right is priv. And that fixes it. So slow would have been none, right? So slow drops off to none. So while right, this just would have like not hit at all, basically, and it would have returned true when it should have returned false. Yeah, it would have basically like skipped that whole while block. That makes sense. Okay, I'm gonna have to practice this one a few times. Yeah, with the when you can copy the array, it's like easy. But if you can't copy the array, I don't know if I'm just tired or what, but it scrambled my brain. Thanks for